Assalamualaikum everyone. So in this video, we will be learning exceedance probability in Python, and we will try to understand it, and then um, we will write Python code. Okay, so let's go here. So let's see exceedance probability. So first, try to understand exceedance probability better. Okay. So if we search exceedance probability, exceedance probability is the likelihood that a value will be exceeded or met. It is a statistical metric used in many fields, including engineering, environmental science, and insurance. Okay, so examples of exceedance probability. So annual exceedance probability (AEP), the likelihood of a flood of a given magnitude occurring within a year. P90, the value that is expected to be exceeded 90% at the time. P75, value that is expected to be 75% of the time. Uh, Environmental science, it is used. Exceedance probability used. Okay, the probability that a certain value will be exceeded in a predefined future time period. The probability that a certain value will be exceeded in a predefined future time period. Exceedance. The frequency of exceedance, sometimes called the annual rate of exceedance, is the frequency with which a random process exceeds some critical value. Typically, the critical value is far from the mean. It is usually defined in terms of number and of peaks of the random process that are outside the bounded frequency of exceedance. Okay, so I think we get the basic idea that the likelihood that a value will be exceeded or met. Okay, um, okay if we go to DeepSeek now, and okay, so uh, I had an exceedance probability code, and first let's uh, okay, so there is exceedance probability code that is generated by ChatGPT, as you can see here. So let's try to run it. Okay, so if we run this code, let's see what it gives us. um, Python 3.5 probability. Okay, it gives the data frame, uh, value, rank. Okay, so this is the value is the rank probability 0.2. This is the lowest probability. Okay, so data frame. Let's sorting the value while we sorting descending order. Ascending false. Left index drop to set index drop to. So I think we understand this part. Input numpy is np and input pandas is pd. Um, Pandas is pd. So no problem here. I think values equals to np dot array 1050. Some values here sample value replace with the value. Um, okay, so df data frame for easy manipulation. Data frame value and values of the values where we can data frame on df. Okay, if we let's say if we print the data frame here, what we will get? Let's say we print the df here. Print df. Let's see what it gives us. See, let's so m value. Uh, this one is showing here, and the values here that is showing. Okay, so if we descend, we are sorting here by descending order. So if we put this here, let's see. So it is not descending order, but if we sort it by descending order and put it here and then run it to see that the highest value has the first place. Okay. So sort values by value ascending false is set index true. What does the sort values? Uh, I think I need more clarification on this part. Okay, so um, let's ask DeepSeek here. Explain this code in simple language. So let's see. This code is used to sort data frame, which is like a table of data based on the values of a specific column. This is the reset the row numbers so they are in order. As simple example breakdown. Df sort value by value ascending for this part sorts the data frame by the column name values. Okay, so there is a column name called value and sorting the data frame. We are sorting the data frame that we have by the values, the column name values, and ascending to ascending false. This means suppose means sorting descending order. Okay, from highest to lowest. Reset index. Uh, reset index. After sorting, the row numbers index might be out of order. This part resets the row numbers so they start from 0 and go up in order. After sorting, the row numbers index might be out of order. Index might be out of order. This part resets the row numbers so they start from 0 and go up in order. Okay, I think this one. If we let's say don't give this part and then run the code, I think yes we will get some random values here. But if we put that part here back, then it will be 0, 1, 2, 3, 4. Okay, so that's the part where we set the index drop true. Um, Drop true means the old row numbers are removed and not added as a new column. The drop equals to true means the old row numbers are removed and not added as a new column. Um, the old row numbers are removed and not added as a new column. In short, this code sorts the table by value column highest to lowest and then members the value neatly. Might be out of order. Might be out of order. This part illustrates how the row numbers. Okay, I understand this part. The drop goes to true means the old row numbers are removed and not added as a new column. Uh, Means the old row numbers are removed. The old row numbers are removed and not added um, as a new column. Okay. Um, Old row numbers are removed and not added as a new column. This is the old row numbers I think and they are removed and not added as a new column. So basically this one is the same as this one. I think that's the part. I can be wrong. Okay, so let's go to our code. Um, okay, so dn equals to period or data frame value. We understand this. Okay, so now what we are doing here. Assign rank 1 for highest group for second highest. This is df rank equals to df index plus 1. Rank starts from 1. Df rank um, df index assigns rank 1 rank 1 for highest, 2 for second highest. Okay, so 14 ranking highest value gets rank 1, second highest gets 2, etc. Since probability computed as rank by total count, meaning the probability of exceeding value. So ranking it df rank equals to df dot index plus 1. Uh, what does this do? Let's ask, let's click here. Uh, let's see. Line of code adds a new column called rank to the data frame df, and it assigns a rank to each row based on its position indexed in the data frame. As a simple explanation, okay, df.index. This refers to the row numbers index of the data frame. By default, row numbers start from 0. This refers to the row numbers index of the data frame. Okay, so df.index refers to this row number uh, number start from 0. Okay, so row number start from 0. This index plus 1. Since row number start from 0, adding 1 ensuring the ranks start from 1 instead of 0. For example, row 0 becomes rank 1. Row 0 becomes rank 1. Uh, row 1 becomes rank 2 and so on. So, okay, so if we, let's say, in the df here, rank starts from 1, okay. If we print the df here, let's see what we get. Okay, so we have added a new column called rank, and uh, first value has rank 1. Okay, so df, since row number starts from 0, adding 1 ensures that the rank starts from 1 instead of 0, for example. Okay, so, I think I have understood, alhamdulillah. So for the first um, row we have value 0, and we want to put the rank 1, and we don't want to put the rank 0 here. That's why we are passing 1 to the df.index. Okay, so I think we have understood it, alhamdulillah. df exceeding probability df rank equals to df rank of df. Okay, so what we are doing here, exceeding probability, we are adding another let's say column called exceeding probability, and we are dividing the rank. Okay, so divided by um, um, let's say the total number of the data frame. Okay, so this is the highest rank, second highest rank. If we print the df here, let's see, uh, and let's see what we get. Okay, so probability 1 by all the values, high 1 by 0.2, second highest probability 0.4, like this. Okay, so I think I've understood it. Print df. So this code is pretty simple, and it is straightforward code. So I think we have understood most of the, uh, not most, I think all of the part. So if you have any doubts or confusion, please um, let me know in the comments. And so that will be all for this video. Thank you.